V in R3 whose coordinate vector with respect to the basis as is -1 3 2. So already we have coordinate vector and we have these three vectors, right? v1 v2 v3. So if you want to find the vector v such that the coordinate vector is -1 3 2 and for this three basis vector, so just we have to take the linear combination of the -1 into 1 2 1 plus 3 into 2 9 0 plus 2 into 3 3 4. So you can see -1 in v1 plus 3 v2 plus 2 v3, that is equal to -1 into 1 2 1 plus 3 into 2 9 0 plus 2 into 3 3 4, and solving this equation we get 11 31 7. So here they complete the solution of this question. Next question, check whether the following are subspace of R3 or not, right? Justify your answer. In this question asked in 4 marks. There are two sub questions, first part and second part. The first is W is equal to A00 where A belongs to R, right? So the first coordinate is any real number and second and third coordinate must be 0. So only those vectors are in the given set in this set such that the first coordinate is real number, second and third coordinate are 0 vector. So let's try to solve this question. First of all, to prove subspace we have to consider we have to take any two vector from the set and try to prove that the addition of that two vector is also in the set and scalar multiplication is also in the set. Okay, but if you want to prove that the given set is not a subspace of a vector space V, in that case the particular example will works, right? So if we take u and v particular and prove that u plus v is not in the set, right, or scalar multiplication is not in the set, then it's enough to prove that the given set is not a subspace. Okay, so for any two vector u is equal to a00 and v is equal to b00 belongs to W, u plus v, that is equal to a00 plus b00 equal to a plus b 00 and k into u, that is equal to k into a00, that is equal to ka 00 belongs to W. Okay, so W is a subspace of R3. W is a subspace of R3, right? You can see because both of the condition are satisfied, the addition of two vector is also in the set and the scalar multiplication is also in the set. So W is a subspace of R3. So next example is XYZ where x square plus y square plus z square is or equal to 1. So only those vectors from R3 are in the set such that the addition of the square of the coordinates is must be less or equal to 1. Okay, so let's try to prove, or let's take some particular example. It's quite easy. See, u is equal to 100 belongs to W, correct? Because 1 square plus 0 square plus 0 square, that is equal to 1 and that is also less or equal to 1. So u is 100 belongs to W, v is equal to 010, that is also belongs to W. But if we see u plus v, that is equal to 110, that is not belongs to W because it's not satisfied the given condition that x square plus y square plus z square is or equal to 1. When we take x square plus y square plus z square, we get 2, right? Since 1 square plus 0 square is greater or equal to 1, it's not less or equal to 1. So u and v both are belongs to W, but u plus v is not belongs to W. So W is not a subspace of R3. Okay, W is not a subspace of R3, right? So here they complete the solution. Next question, question 4a. Find the rank and nullity of the matrix A. Here is a 3 cross 3 matrix, 1 minus 1 3, 5 minus 4 minus 4 and 7 minus 6 2, right? This question asked in 4 marks. Again is the same matrix, right? Here is the solution starting with the A is equal to 1 minus 1 3, 5 minus 4 minus 4, and 7 minus 6 2. We have to convert first of all the given matrix into a row echelon form. So that's why we multiply first row with minus 5 and add into the second row, and then we multiply first row with minus 7 and add into the third row, right? That these two processes are our first process. So when we multiply first row with minus 5 and add into the second row, what will become the second row? 0 minus 4 minus 4 plus 5, right? So that is 1 minus 4 minus 15, that is minus 19. So 0 1 minus 19, correct? Next is we multiply first row with minus 7 and add into the third row. So 7 minus 7 0, minus 6 minus 1 into 7, minus 7, right? So that is minus 6 plus 7, that is 1, and 2 minus 7 into 3, that is 2 minus 21, minus 19. So 0 1 minus 19. You can see second and third row are same. So when we multiply second row with minus 1 and add into the third row become 0, right? So that is the next process. We multiply second row with minus 1 and add into the third row. So the last matrix is in row echelon form. You can see the last matrix is in row echelon form. Okay. How many non-zero row? Only 2 non-zero rows, right? So that's why rank is equal to number of non-zero row in the row echelon form matrix, that is equal to 2. Now here is we use rank nullity theorem to find nullity. We have one theorem that rank plus nullity, that is exactly the number of column of the matrix A. So rank is 2, nullity plus nullity, and the number of column of A, that is equal to 3. So nullity of A is equal to 3 minus 2, that is equal to 1. Okay, so nullity of A is equal to 1. So here the complete the solution of this question. Next question. Question 4b. Let S is equal to V1, V2, V3 be the basis for R3, where V1 is equal to 1 1 1, V2 is equal to 1 1 0, and V3 is equal to 1 0 0. Let T from R3 to R3 be the linear operator such that T of V1 is equal to 2 minus 1 4, T of V2 is equal to 3 0 1, T of V3, that is equal to minus 1 5 1. Find the formula for T of x1 x2 x3 and then compute T of 2 4 minus 1. So let U is equal to xyz belongs to R3, then U can be expressed as U is equal to xyz, that is equal to A V1 plus B V2 plus C V3. So U is equal to xyz, that is equal to A into V1, that is 1 1 1. Because of V1, V2, V3 are basis vector, so any vector of R3 can be expressed as linear combination of this three basis vector V1, V2, V3, right? So xyz, that is equal to A V1 plus B V2 plus C V3. Put the value of V1, V2, V3. xyz, that is equal to A into 1 1 1 plus B into 1 1 0 plus C into 1 0 0. So xyz is equal to A plus B plus C, A plus B, and then A. So A is equal to Z, A plus B is equal to Y, right? And A plus B plus C is equal to X. So put the value of A in this second equation, we get B is equal to Y minus Z, and put the value of A and B in the first equation, we get C is equal to X minus Y. So put the value of A, B and C in this equation, xyz is equal to A V1 plus B V2 plus C V3. So xyz is equal to zv1 because a is equal to z, so zv1 plus bv2. But what is b? B is y minus z. Okay, so y minus z into v2 plus cv3. What is c? C is x minus y, so x minus y into v3. Now operate t, transformation t on both the side, and we know that t is a linear transformation, so we can write down this equation: t of xyz, that is equal to z into t of v1 plus y minus z into t of v2 plus x minus y into t of v3. Okay, now put the value of t of v1, t of v2 and t of v3. You can see t of v1 is 2 minus 1 4, t of v2 is 3 0 1, t of v3 is minus 1 5 1. So here we put the value t of v1, t of v2 and t of v3. So z into 2 minus 1 4 plus y minus z into 3 0 1 plus x minus y into minus 1 5 1. So 2z minus z 4z, multiply z in this vector, we get 2z minus z 4z plus y minus z into 3 0 1, so we get 3y minus 3z, then 0, and y minus z plus x minus y into minus 1 5 1, so we get y minus x, 5x minus 5y, and then x minus y. Okay, just addition of these three vectors, finally we get easily minus x plus 4y minus z, then 5x minus 5y minus z, then x plus 3y. Okay, so finally t of xyz is equal to, we get minus x plus 4y plus z, 5x minus 5y minus z, and x plus 3y. So this gives the formula t of xyz, that is equal to, now also we want to find the value of t of 2 4 minus 1. So you can see t of 2 4 minus 1, instead of x, y and z we have to put the value of 2 4 minus 1 respectively. So this become minus 2 plus 16 plus 1, right? So that is 15, minus 2 plus 16 plus 1, that is 15. Then 5 into 2 minus 5 into 4, that is 10 minus 20 plus 1, so that is minus 9. And then 2 plus 3 into 4, that is 2 plus 12, right? So that is 14. So this is actually 14, not 1, right? So 2 plus 12 is 14. So here is the complete the solution. The next question. Determine whether the given function is a linear transformation or not, right? Justify your answer. So here is the two example. First one is transformation T is from set of n cross n matrix to R, where T of A is equal to trace of A. And the second one is the transformation T of set of n cross n matrix to R, where T of A is equal to determinant of A. So this question asks in 4 marks. Set of n cross n matrix to R. So T of A plus B. First one is transformation T of A is equal to trace of A. Now what is trace of A? That we know that the sum of the elements of the principal diagonal. Okay, so starting with to prove that the given transformation is linear, or to check that the given transformation is linear or not, the two condition must be satisfied, that is T of u plus v, that is equal to T of u plus T of v, and T of k into u, that is equal to k into T of u, where u and v are the vectors of the domain, right? So here we have domain set of n cross n matrix, so that's why we take the two matrices A, capital A and capital B. So here we have to prove T of A plus B, that is equal to T of A plus T of B, and T of K into A, that is equal to K into T of A. If these two conditions are satisfied, then we can say that the given transformation is a linear transformation. Okay. So to prove first one, you can see T of A plus B, that is equal to trace of A plus B, that is equal to trace of A plus trace of B. Okay, because it's quite easy to check that the trace of A plus B, that is equal to trace of A plus trace of B. In fact, this is a property of this function trace of A, and that is equal to T of A plus T of B, right? So the linearity, the first condition is satisfied for linear. T of K into A, that is equal to trace of K into A, that is equal to K into trace of A, that is equal to K into T of A. Okay. So T is a linear transformation. For T is a linear transformation. Next one is transformation T is coming from set of n cross n matrix to R, where T of A is equal to determinant of A. Now the answer is this is not a linear transformation, and that you can understand from this example, right? A is equal to 1 0 0 1, 2 cross 2 matrix. B is equal to -1 0 0 -1, 2 cross 2 matrix. What is determinant of A? 1, right? What is determinant of B? That is also 1. Now what is A plus B? This is our A plus B. A plus B is 0 0 0 0. Okay. A is 1 0 0 1, B is -1 0 0 -1. So what is A plus B? 0 0 0 0, correct? And determinant of A is 1, determinant of B is 1, but determinant of A plus B, that is equal to 0. Okay. So determinant of A plus B, that is not equal to determinant of A plus determinant of B. So T of A plus B, that is not equal to T of A plus T of B. So T is not a linear transformation. Okay. And here they complete the solution. The next question, or question 4, or let T from R2 to R3 be the linear transformation defined by T of x1 x2, that is equal to -x2